Hey everyone, today we are going to solve the Daily LeetCode challenge of 15th March 2024. And the problem statement is product of array except self. So let us first understand the problem statement. So according to the problem statement, we have been given an integer array nums and we have to find the product of array except self. Now what does it mean? It means that we have to return an answer which would be a vector of the same size as that of nums. So it means that this answer will have a size of 4. And if we are in the 0th index, so what does answer of 0 will contain? It will contain the product of all the elements of nums except the element present in the 0th index. So what does it mean? It means that in the 0th index, we'll store 2 into 3 into 4. We'll store 2 into 3 into 4. And we won't include the element present at the 0th index. And what is the element present in the 0th index in nums? It's 1. So we won't include this one. Similarly, what will answer of 1 contain? Answer of 1 will contain the product of all the elements of nums except the value present at the 1th index. What is the value present in the 1th index? It's 2. So we won't include 2. And except for that, we'll return the entire product of direct. So what it would be? It would be 1 into 3 into 4, correct? We'll include 1, we'll include 3, we'll include 4, and we won't include 2. Similarly, what will be in answer of 2? Answer of 2 will contain the product of all the elements except the one present in the second index. So which element is present in the second index? It's 3, right? If we'll index them, so we have 3 in the second index. So what we will have in answer of 2? Answer of 2 will contain 1 into 2 into 4, correct? And what will answer of 3 contain? Answer of 3 will contain the product of all the elements except the one present at the third index, right? So it means that we will exclude this 4. So what we will have? We'll have 1 into 2 into 3, correct? So now that you have understood the problem, let's see how we can solve this. So I'll be explaining 3 approaches for solving this problem. Let us first discuss the approach 1. So what we will do in the first approach is, say for example, if this is the array given to us, so if I'm present at this element 1, so what we'll do, we'll run a for loop and we'll find out the product of all the elements except this one. So what we'll get? We'll get 2 into 3 into 4, which is 24, correct? Then we'll move to the next element, which is 2. Now again, what I'll do, I'll find the product of the entire array except this 2. So what we'll get? We'll get 1 into 3 into 4, which is 12. Fine. Now again, I'll move to the next element. And what I will do, now again, I'll find the product of the entire array except for this 3. So what we'll get? We'll get 1 into 2 into 4, which is 8. Now again, we'll move forward. Now we are at 4. So what we'll do, we'll find the product of the entire array except for this 4. So what we'll get? We'll get 1 into 2 into 3, which is 6. Okay. And this is the answer. Fine. Now one thing you have noticed over here is that we are using a for loop to iterate over all these elements, right? Initially, we were at 1, then we found the product, then we moved to 2, then we moved to 3, and so on. So we will have a for loop. So what we'll do, we will have a for loop such that, let's say that's a variable I and it will run from 0 to n. Why? Because we have to iterate over all the n elements, right? And one more thing is that you may have noticed that we are running another for loop. Say, for example, it's j and it's also running from 0 to n. And why are we using this second for loop? We are using this second for loop to find out the product, correct? When we were at this element 1, what we did? We iterated over the entire array to find the product, right? And when we were at 2, we again iterated over the entire array to find the product. So we will have another for loop which we will use to find the product. Okay. Now, when we want to find the product, we want to find the product only when this ith index is not equals to this jth index, right? If this ith index is not equals to the jth index, then what we'll say? We'll say that product is equal to product into nums of j. Fine. Now, why have I written this condition? Because whenever our ith pointer and jth pointer would be same, in that case, we don't want to include it, right? Say, for example, if our ith pointer is at 1, correct? And our jth pointer is also at 1. And what I am finding at this particular point, I am finding answer of I, right? I am finding answer for the 0th index. So I don't want to include the same element, right? I don't want to include the element present in the 0th index when I am finding answer of 0, because we want to find the product of array except self, correct? So that's the reason why we have included this statement that if I is not equal to j, then only we are going to find the product. Now let's do a quick try run to get a better understanding of this. So initially our answer would be an empty array which will have the same size as that of nums. We will take product initially as 1 and our ith pointer is at the 0th index. Okay, this is our ith pointer. And initially our jth pointer is also at the 0th index. So here is our jth pointer. Okay. So now what we'll do, we'll check that is this ith pointer equals to jth pointer. So here we can see that ith pointer is equal to jth pointer. So are we going to find the product? We are not going to find the product. Why? Because here what we are finding out answer of I. What is answer of I? Answer of I is 0, answer of 0, correct? And in answer of 0, we don't want to include the element present at the 0th index. Fine. So what we'll do, we'll simply move the jth pointer forward. So the value of j will now become 1. So now our jth pointer is over here. Okay. Now we'll check, is the ith pointer not equals to jth pointer? So ith pointer is not equal to jth pointer. So what we'll do, we'll find the product. We'll multiply this element 2. So product will become 2. Correct? Now what we'll do, our jth pointer will again get incremented. It will now become 2. So now we are at this element. So again, ith pointer and jth pointer is not equal. So what we'll do, we'll find the product. So we'll multiply 3 over here. Okay. So what we have got? We have got 6 up till now. Now what we'll do, we'll again increment the jth pointer. So jth pointer will point at the 3rd index. Okay. So now again the ith pointer and the jth pointer are not equal. So we'll find the product. So what we'll do, we'll multiply 4 over here. So what we have got at the product is 24. Now again we'll increment the jth pointer. So the jth pointer now will become equal to the 4th index. 4th index doesn't exist. So what does it mean? It means that we have calculated answer of I. What answer of I? Answer of I is answer of 0. So what we will store? We will store 24 in answer of 0. So we will have 24 over here. Okay. Now that we have found out answer of 0, now we want to find out answer of 1. So what we'll do? We will again set our product back to 1. Okay. Now what will happen? Now our ith index will get incremented and it will point over here. Fine. So now our ith pointer is at 1 and the value and the jth pointer would be initially at 0. Okay, so here is the jth pointer. So now we'll check that is ith pointer not equal to jth pointer. So yeah, they are not equal. So what we'll do, we'll find out the product. So what we will do over here, we will multiply nums of j with product. What is nums of j? It's 1, correct? So we will multiply 1 over here. Okay, and we'll get 1. Now our jth pointer will get incremented to 1. So our jth pointer will now point over here. So we will check, is our ith pointer and jth pointer not equal? So it's false. Ith pointer and jth pointer has become equal. So are we going to find the product? We are not going to find the product. Why? Because you can notice that what we are finding now, we are finding answer of 1, correct? And since we are finding answer of 1, so we don't want to include the value present at the 1th index, right? So what we'll do, we'll simply move the jth pointer. So the jth pointer will now point at the index 2. Now again we'll check, is the ith index not equals to the jth index? So we can see that ith index and jth index are not equal. So what we'll do, we'll simply multiply nums of j to our product. So we'll multiply 3, we'll get a 3 over here. Okay. Now again our jth pointer will get incremented. Now it will point to the index 3. So again we'll check that is ith pointer and jth pointer not equal. So they are not equal. So what we'll do, we'll find out the product. And how are we going to do? We are going to simply multiply nums of j to it. So what is nums of j? Nums of j is 4. So we are going to multiply 4 over here, we'll get at 12. Again, jth pointer will get incremented. It will now point at 4. So if 4 doesn't exist, what does it mean? It means that we have found out answer of 1. Why answer of 1? Because our I was 1, right? So we have found out answer of 1 and what is it? It's 12. Now that we have found out answer of 1, now again our product will get reset, okay, to 1. And now what will happen? Our ith pointer will move forward. It will now point at the 2nd index. So our ith pointer is pointing at 2nd index. They would be initially pointing at 0. So here is the jth pointer. Okay. Now what we'll check, is the ith pointer not equal to the jth pointer? So ith pointer and jth pointer are not equal. So what we'll do, we'll multiply nums of j to our product. What is nums of j? It's 1. So what we'll get 1 as the product. Now what we'll do, we'll increment the jth pointer. So the jth pointer is pointing at the 1th index. Now again we'll check jth pointer and ith pointer are not equal. So what we'll do, we'll multiply nums of j to our product. So we'll get 2 over here, correct? Now again we'll increment the jth pointer. So jth pointer will now become equal to 2. So now we can say that is ith pointer not equal to jth pointer? So it's false, right? Ith pointer and jth pointer are equal. So are we going to find the product? We are not going to find the product, right? So what we'll do, we'll simply increment the jth pointer and it will point at the index 3. Fine. Now we'll check that ith pointer and jth pointer are not equal. So they are not equal. So what we'll do, we'll simply multiply nums of j to our product. What is nums of j? It's 4. So we'll multiply 4 to our product and we'll get 8. Now again jth pointer will get incremented. Now it will become 4. 4th index doesn't exist. So what does it mean? It means that we have successfully found out answer of 2, right? And what it would be? It would be 8. Now that we have calculated answer of 2, now what will happen? Our product will again get reset to 1 and our ith pointer will move forward. So now our ith pointer is pointing at the index 3. and jth pointer would be again initially 0. Correct? So here is our jth pointer. Now we'll check, is the ith pointer and the jth pointer equal? So ith pointer and jth pointer are not equal. So what we'll do, we'll multiply nums of j to the product and we'll get 1 over here. Now what will happen? The jth pointer will get incremented to 1. We'll move this forward. Now again we'll check, is the jth pointer ith pointer equal? So they are not equal. So what we'll do, since they are not equal, we'll find the product. What are we going to do? We are going to multiply nums of j. So we'll multiply nums of j, we'll get a 2. Now what will happen? Jth pointer will move forward. It will get incremented to 2. Now again, jth pointer, ith pointer not equal. So what we'll do, we'll find the product. So what are we going to do? We are going to multiply nums of j, which is 3. So what we'll get? We'll get 6 over here. Now what will happen? Jth pointer will again move forward. It will get incremented to 3. Now we'll check. Jth pointer and ith pointer not equal. So it will give false. Why? Because ith pointer and jth pointer are equal. Right? So are we going to find the product? We are not going to find the product. Then what will happen? Jth pointer will move forward. It will get incremented to 4. Fourth index doesn't exist. It means that we have successfully found out answer of 3. And what would be answer of 3? It would be nothing but 6. Correct? And what will happen, since we have found out the product for answer of 3? So what will happen? The product will again get reset to 1. And our ith pointer will move forward. So the ith pointer will now point at index 4. Correct? Ith pointer will point out index 4. So does index 4 exist? Index 4 doesn't exist. So what does it mean? It means that we have successfully found out the answer, which is this. Correct? So this is the first approach. And now talking about the time complexity and space complexity of this approach. So the time complexity would be order of n square. Why? You can clearly see that we are having first for loop in which we are using this ith pointer to iterate over all the elements of nums, right? We were iterating over all the elements of nums using this ith pointer. So we are having another for loop j, which is again starting from the 0th index and going up till n. And what we are doing, we are using this second for loop to find the product. Correct? So we are having two for loops such that one is inside the another. So since we have a nested for loop, the time complexity would be order of n square. Okay, considering that n is the size of the array, size of array. Fine. And what would be the space complexity? This, we are not using any extra space from our end. Correct. So the space complexity would be order of 1. Now, as you can see that the time complexity of order of n square. So can we have a better approach that can have a time complexity lesser than this? So the answer to this is yes. So let's quickly discuss the second approach. So as you all saw in the previous approach, that what we were doing, say for example, if I'm present at this element, we were iterating over the array to find the product, right? And if I was at this index, I was iterating over the array again to find the product, correct? So for each of the element, what we were doing, we were iterating over the entire element again and again. So can we have a better solution in which we don't have to iterate over the array again and again for each of the specific element? So the answer to that is yes. So let's see how we can do it. Say for example, if I'm present at this element 3. So what would be the product of the array except this 3? So it would be the product of all the elements before 3 and all the elements after 3, correct? Now what is the product of the element before 3? It's 2 into 1, which is 2. And what is the product of the element after 3? It's 4. So 2 into 4, we will get 8 over here, correct? Similarly, if I'm present at the element 2, so what would be the product of the array except this 2? It would be the product of the elements before 2 and the product of the elements after 2. So what is the product of the element before 2? It's 1 into what is the product of the element after 2? It's 3 into 4, which is what? 12. So what we'll get over here? We'll get 12, correct? Similarly, if I'm present at this 4, so what would be the product of the array except this 4? It would be the product of the elements before this 4 and the product of the elements after this 4. Now, what is the product of the element before 4? It's 1 into 2 into 3, which is what? Which is 6. And what is the product of the element after 4? Now, you can see that we don't have any elements after this 4, correct? So, shall we write 0 over here? So, the answer is no. Why? Because if I write 0 over here, the answer will become 0. Is this correct? It's wrong, right? So what we'll do, we will write 1 over here. Why? Because we are finding out product, right? Whenever we used to find sum, in that case, it makes sense to write 0. But whenever we are finding out the product, it makes sense to write a 1 because 6 into 1 will give us 6, which is correct. What is the array? What is the product of the array except this 4? It would be 1 into 2 into 3 only, right? Which is 6, correct? Similarly, if we are at this element 1, so what would be the product of the array except this 1? It would be the product of the elements before 1 and the product of the elements after 1. So what is the product of the elements after this one? It is 4 into 3 into 2, which is what? 4 2s are 8, 8 3s are 24, which is 24. And what is the product of element before 1? Now, since we don't have any more elements before 1, so what should we write over here? We should write 1 over here. Because Only if 24 will get multiplied by 1, we will get a 24 over here. Okay. Now, you can see that we have found out the answer, which is 24 for answer of 0, 12, 8, 6. So, this would be our answer. Now, did we notice the pattern over here? So, the answer is yes. So, at each of the index, say for example, if this is an array, okay, if this is an array and we are present at the ith index, okay. So, what would be answer of I? What would be answer of I? Answer of I would be the product of elements before it, correct? And the product of element after it. So if we find out the product of elements before it and after it, so we can simply multiply those two to get the answer, correct? So what pattern did we notice? We noticed that what we can do is we can store the prefix product. We can store the prefix product. Say for example, if we are at this index I, so what would be the prefix product? The prefix product would be the multiplication of this and this element, correct? And we can also store the suffix product. And what would be the suffix product if we are present at this index? It would be the multiplication of this and this element, correct? And what we can do is once we have found out the prefix product and the suffix product, what we can do, we can iterate, we can run another for loop and we can simply multiply the prefix product and suffix product, because what we were doing over here, if we are present at this element 3, what was this 2? This 2 was nothing but the prefix product, right, which is 1 into 2. And what is this 4? This 4 is nothing but the suffix product, right, which is 4. And what we did, we first find out the prefix product, then we found out the suffix product, and what we did, we multiplied them to get the answer, right? So what we can do is we can find the prefix product, we can find the suffix product, and later on, once we have found out the prefix product and suffix product, we can simply multiply them, get the answer, right? We can get the answer of I simply. And one more thing to note is that when we are present at the last element, correct? Say for example, this 4 is the last element, right? So whenever we are present at the last element, in that case, what would be the suffix product? The suffix product would be 1. Why? Because we don't have any elements towards the left of 4, right? So what would be the element present at the last index of this suffix? It would be 1, correct? It would be this 1. Similarly, we can notice one more thing, that when we are present at this 1, which is the first element of the array, correct? So since we don't have any elements before this 1, we don't have any elements before this 1. So here you can see that the prefix product, this is the prefix, this is the suffix, right? So in this case, the prefix product is 1, since we don't have any element, right? So what would be the first element of the prefix product? It would be 1, okay? So we noticed that we found out the pattern that the last element of suffix product would be 1 and the first product of the prefix product would be 1. Now say for example, if I am at an index I, then how are we going to find prefix of I? So prefix of I would be prefix of I minus 1 into nums of I minus 1. Similarly, how are we going to find the suffix? So suffix of I would be suffix of I plus 1 into nums of I plus 1. Okay. Now let's do a quick dry run so that we can understand this in a better way. So what we discussed initially, the prefix of 0 would be 1 and the suffix, the last element of the suffix array would be 1. Okay. So let's first find out the prefix, later we'll find out suffix. Okay. So since we have already populated the element for the 0th index of this prefix array, so we will start iterating from the first index, right? So our ith pointer is at index 1. Okay. So what did we said? How are we going to find prefix of I? Prefix of I would be prefix of I minus 1. What is prefix of I minus 1? Prefix of I minus 1 is prefix of 0, which is what? Which is 1, correct? So we will have 1 into, what we have to multiply? We have to multiply nums of I minus 1. What is nums of I minus 1? It's 1, right? So we have to multiply 1 into 1, which would be what? Which would be 1. So we will store 1 over here. Additionally, you can see that what was this one? This one was the prefix product, right? And what is the prefix product? It's 1. So it means it's correct. Okay. So now our ith pointer will get incremented with, and it will point to index 2. Okay. So what would be the prefix product? The prefix product would be prefix of I minus 1. So prefix of I minus 1 means prefix of 1. So what is prefix of 1? Prefix of 1 is 1. So we will have 1 into nums of I minus 1. What is nums of I minus 1? Nums of I minus 1 means nums of 1. What is nums of 1? Nums of 1 is 2. So we will multiply 2 over here and we will get 2 and we will store this 2. Additionally, you can see that what was the prefix product? It was 2, correct? Now what we'll do, we'll increment the ith pointer. Now the ith pointer will point at the third index. Okay. So what we have to do, we have to multiply prefix of 2. So what is prefix of 2? Prefix of 2 is 2 And nums of 2, what is nums of 2? Nums of 2 is 3. So we'll multiply this 3 and we'll get a 6 and we'll store the 6. And you can also see that the prefix product was 6. Okay. So what we did over here is we used the prefix product that we have calculated till now, which was 2, and we multiplied the previous element, which was 3, to get this prefix product, right? And you can also see that what is it? It's 6 only, correct? Now we'll again increment the ith pointer. Now the ith pointer is pointing at the index 4. Index 4 doesn't exist. So it means that we have successfully populated the prefix product. Now what we have to populate? We have to populate the suffix product. Now while calculating the prefix product, we moved from left to right. Correct. Now while calculating the suffix product, we will move from right to left. Why from right left? Because which value we know? We know the value stored at the last index. Correct. So it makes sense to move from right to left. So since we have already calculated suffix of 3, so we will start iterating from the second index. So our ith pointer will point at this index, correct? So now what we have to do, what would be our suffix of I? Suffix of I would be suffix of I plus 1. What is suffix of I plus 1? Suffix of I plus 1 means suffix of 3. What is suffix of 3? Suffix of 3 is 1 into nums of I plus 1. What is nums of I plus 1? I is over here. I plus 1 means index 3. So nums of index 3 is 4. So we are going to multiply this 4. So what we'll get? We'll get 4. We'll store this 4 over here. And you can also see that if we are at this index I, what is the suffix product? The suffix product is nothing but 4, correct? Now what we'll do? We'll decrement the ith pointer. So now ith pointer is pointing at index 1. Now what would be suffix product? The suffix product would be suffix of I plus 1. So what is I plus 1? I is over here. So I plus 1 means index 2. So suffix of 2 is what? Suffix of 2 is nothing but 4. So we'll multiply this 4 and the nums of I plus 1. What is nums of I plus 1? It's 3. So we'll multiply this 3, we'll get a 12 and we'll store it. Additionally, you can see that here, what is the suffix product? Here the suffix product is 12. Now again, our ith pointer will get decremented and it will point at the index 0. Okay. Now, what would be suffix of index 0? Suffix of index 0 would be suffix of 1. So what is suffix of 1? It's 12 into suffix of nums of 1. What is nums of 1? It's 2, correct? So it would be 24. So what we will do, we'll store this 24. Now again, our ith index will get decremented. Now it is pointing at -1 and that index doesn't exist. So what does it mean? It means that we have successfully calculated the suffix as well. Now, what did we discuss? We discussed that if this is an array and if we are at this index I, so what would be our answer of I? Our answer of I would be the prefix product into the suffix product. So what would be answer of I? Answer of I would be the prefix of I into the suffix of I. Correct? Suffix of I. Now what we have to do, we have found out the prefix, we have found out the suffix. Now we will iterate over these two array to find out answer of I. What would be answer of I? Say for example, if the value of I is 0, so let me draw it like this. So we will have the 0th index, first index, second index. So this will be 0, 1, 2, 3, correct? So if I is 0, so what would be answer of I? Answer of I would be prefix of 0 into suffix of 0. So it would be 1 into 24, which is 24. Now I will get incremented to 1. So what would be answer of 1? Answer of 1 would be prefix of 1 into suffix of 1, which would be 12. Okay. Now I will get incremented to 2. Now what would be answer of 2? Answer of 2 would be prefix of 2 into suffix of 2. So it would be 4 to the 8. I will get incremented to 3. Now what would be answer of 3? Answer of 3 would be prefix of 3 into suffix of 3, which is 6 into 1 will give us 6. And this is the answer. Correct? Now I hope that this approach is understood to you all. Now let's quickly code this. So we will start on by creating a vector answer whose size would be equal to the size of nums array. Correct? So let's find the size of the nums array. So it would be nums of size. So its size would be n. So let me take initially all the value of answers as 0. Let us create another 2 vectors. And what would be those 2 vectors? We have to create this prefix and this suffix. Correct? Vector int prefix. And its size will be also n. Let me take initially all its value as 1. And we'll have to create another vector suffix of size n. Initially all the value will be 1. Now what we have to do? Now we have to populate this prefix and suffix. So let's first populate the prefix. So let's run a for loop in index equals to 1, index less than n, index plus plus. Now you may ask that why I have started this index from 1. So you can notice over here that prefix of 0 is always 1, correct? So there is no sense of starting this for loop from index 0, correct? And what would be prefix of index? Prefix of index would be, it would be prefix of index -1 into nums of index -1, correct? So we will have prefix of index -1 into nums of index -1, correct? Now, once we have populated this prefix array, what we have to do? We have to populate the suffix array. So we'll say index is equal to n minus 2, index greater than equal to 0, index minus minus. Now you may ask that why I have started from index as n minus 2 and not from n minus 1. The reason being that the last element of suffix will always be 1. So there is no sense of starting the loop from n minus 1. Correct. Now let's store suffix of index as suffix of index plus 1 into nums of index plus 1. Correct. Now, once we have populated the prefix and the suffix, what we have to do is we have to populate the answer. So what we'll do, we'll simply start index iterating from the 0th index up till the nth index. And we'll say index plus plus. And what would be answer of I? Answer of index would be prefix of index into suffix of index. Correct. Suffix of index. Now what we have to do, we have to simply return our answer. Now let's run this. So it's giving us the correct answer. Let's submit it. And it got accepted. Talking about the time complexity and space complexity. So if we consider the size of the array as n, then the time complexity is order of n. Why? So here you can notice that what we are doing over here, we are iterating over the entire array to populate this prefix. So we will be iterating over n elements, correct? So it will cost us order of n. Similarly, here again we are iterating over all the elements, right, to populate suffix. So it will again cost us order of n, and here as well, again we are having another for loop which will cost us order of n. So the time complexity would be order of 3n, which since 3 is the constant, so we can ignore it. So ultimately our time complexity would be order of n only, correct? And the space complexity is order of n. Why? Because here you can see that we are using two vectors, correct? Prefix and suffix. And size of both of them is n. So we will have a size of 2n. So we will have space complexity as order of 2n, which would be ultimately order of n only. Okay. So this was all about the first approach. But here you can notice that we have a follow-up question, that is, can you solve the problem in order of 1 extra space? And here we were using order of n space, right? So let's see how we can solve this problem using no extra space. Now, as you all saw that in this approach, what we were doing, we were using an array to store prefix, and then we were using another array to store suffix, and then we multiplied both of them and stored its result in answer, right? So we were using extra two arrays. So can we reduce it? Like, can we use simply the answer array instead of using a prefix and suffix? Because if we directly use this answer, then we will not use any extra space, correct? Because this answer is not counted as an extra space. These two arrays are getting counted as an extra space. So can we do it like that? So the answer is yes. So let's quickly discuss the third approach. Now in the second approach, what we were doing, we were first storing the prefix in the prefix array. So in the third approach, what we will do, we will use the answer array to store the prefix. So how we can store the prefix? So it would be answer of I minus 1 into nums of I minus 1. So in this way, what we will store in the answer array? In the answer array, we will firstly store all the prefix product, correct? Now, once we have stored the prefix product in the answer array, after that, what we will do is we'll find the suffix product, and at the same time, we will multiply it with the answer of I. Why? Because what is answer of I? What we were getting in the answer? It was nothing but the prefix product into suffix product. So we have already calculated the prefix product. Now what we have to do is we have to just calculate the suffix product and multiply it with the prefix product, correct? So let's do a quick dry run, then it would be easier to understand. So initially we will have a vector answer which will have the same size as that of nums, okay? And now first what we have to do, we have to find the prefix product. While finding out the prefix product, we know that the prefix of 0 will always be 1, correct? So here we will store 1 in answer of 0. And since we already have the value in answer of 0, so it doesn't make sense to iterate from the 0th index. So we will start iterating from the first index, okay? So currently we are at the index 1. So what would be the prefix product? The prefix product would be answer of I minus 1. So what is answer of I minus 1? Answer of I minus 1 is answer of 0. So what we have in answer of 0? Answer of 0 is 1. So it would be answer of 0 into nums of 0. So what is nums of 0? Nums of 0 is 1. So what we will get? We will get 1 into 1, which is 1. So we will store 1 over here and we'll increment the ith pointer. So the ith pointer will now point at the index 2. So since we are at the second index, so what would be the prefix product? So prefix product would be answer of 1. So what is answer of 1? It's 1 into nums of 1. What is nums of 1? It's 2. So what we'll get? We'll get a 2 over here. And we will increment the ith pointer. So the ith pointer is now pointing at the third index. Okay. Now what would be the prefix product? The prefix product would be answer of 2, which is 2 into nums of 2. So nums of 2 is what? It's 3. So we will get a 6 over here. Now again we will increment the ith pointer. So the ith pointer is now pointing at the fourth index and it doesn't exist. So what does it mean? It means that we have successfully found out the prefix product. Also, you can see that what is answer of 0? Answer of 0 is 1. Prefix product is also 1. What is answer of 1? It's 1. Prefix product is 1. Correct. Answer of 2 is what? It's 2. Prefix product is 2. Correct. Answer of 3 is what? It's 6. Prefix product is 6. Correct. So we have successfully found out the prefix product. So in approach to what we were doing, we were first finding out the prefix product. Similarly, in approach 3, we have successfully found out the prefix product. Now what we want to do, we want to find the suffix product, right? We were finding out the suffix product here. Now we want to find the suffix product using only the answer vector. So let's see how we can do it. Now for finding the suffix product, what we will do, we will make use of a variable called suffix, which will help us to keep track of the suffix product. Okay. So initially suffix is 1. Why it is 1? Because you can see that what is the suffix product of the very last element? It's 1. Correct. So we will start iterating from here. Okay. So how are we going to find out the suffix product? So we will find out the suffix product and at the same time we will populate the answer. So what would be our answer? Answer of I is what? Answer of I, here we can see what is answer of I. Answer of I is nothing but prefix into suffix. So we have already stored prefix in answer of I only. Okay. So what we will do now, we will update answer of I as answer of I, which is what? This answer of I is nothing but prefix because we have stored prefix product in the answer of I. Correct. So it would be prefix into this suffix variable. So we will multiply this suffix variable with this prefix and we will successfully get the answer. So let's see. So currently our pointer is at the third index. So what would be answer of 3? Answer of 3 would be answer of I. What is answer of I? Answer of I is 6. So it would be 6 into suffix. Suffix is 1. So this will get updated to 6 only. Correct? Now what we will do? Now we will update our suffix. Now once we have populated answer of I, we will update our suffix as suffix into nums of I. Correct. Now what is nums of I? Nums of I was 4. So we will multiply this 4 and we will move this ith pointer over here. Okay. Now what will be our suffix? Our suffix will be now 4. Okay. Now again we will say that answer of I. Now where is our ith pointer? Ith pointer is at the second index. So what would be answer of I? Answer of I would be answer of I. So what is answer of I? It's 2. So we'll have 2 into suffix. What is suffix? Suffix is now 4. So we'll have 2 into 4, which is 8. Correct. So what we will store over here in answer of I, will store 8. Okay. Now what we will do once we have populated answer of I, what we were doing, we were updating our suffix. So what would be suffix? Suffix would be suffix into nums of I. What is nums of I? It's 3. So it would be 12 over here and we will move the ith pointer over here. Additionally, you can see that when we are present at this element 2, what is the suffix in that case? The suffix is 12, correct? And what are we getting as suffix? It's 12, right? Now at this point, what would be our answer of I? Answer of I would be answer of I, which is 1 into suffix. What is suffix? It's 12. So what we will get? This will get updated to 12. Now what we will do? We will update the suffix. So what would be suffix? Suffix would be 12 into nums of I. What is nums of I? It's 2. So it would be 24. And we'll move the ith pointer over here. Additionally, you can see that when we are present at the first index, what we have as the suffix? We have 24 only as the suffix, correct? And what we have as the prefix? It's 1. What we will do? Now we are present at the 0th index. So what would be answer of 0? Answer of 0 would be answer of 0 into suffix. What is suffix? Is nothing but 24. So what we will get over here? It will get updated to 24. So what is our answer? In our answer, we have 24, 12, 8 and 6, which is the result. So now we have seen that how we can solve this problem using only a constant space complexity. Okay. So now let's quickly code this. So let's update the previous code only. Now in this new approach, we are not using any extra arrays. So we don't need this prefix and this suffix array. So we'll simply remove it. We'll set all the value of answer initially as 1. Why are we doing this? Because answer of 0 will always be 1. Why? Because we are first storing prefix, right? First we are storing the prefix product. And what we saw that in prefix product, prefix of 0 is always 1. Okay. Now what we have to do? We have to find out the prefix product. So what would be here? It would be answer. So what we are doing? First we are storing prefix product in answer. So what we are doing here? We are storing prefix product in answer, right? Store prefix product in answer. Now, once we have stored prefix product in answer, what we were doing? See, here we have successfully stored prefix product in answer. Now, what we were doing? We were storing the suffix product and we were updating the suffix, correct? So now what we have to do? Let's remove all these two for loops. Now what we have to do? We have to take a variable, say suffix, which would be initially 1. Why? Because the suffix product of the very last element will always be 1, correct? So let's take suffix as 1 and we will start iterating from n minus 1 and we'll go up to index is greater than equal to 0 and index minus minus. Now what we have to do? Answer of index would be answer of index into suffix, correct? Because in the second approach, what we did, what we were doing is what was answer of I? Answer of I was prefix into suffix, correct? And in the third approach, what we did, instead of using this prefix array, we were storing this prefix product in answer only. So what would be answer of I? Answer of I would be nothing but answer of I into suffix. What is this suffix? This suffix is the suffix product. And what is this answer of I? This answer of I is nothing but prefix only, correct? So here we'll have answer of index into suffix. Once we have populated answer of index, what we have to do? We have to update our suffix. So what would be suffix? Suffix would be suffix into nums of index. Fine. And finally, we will be returning the answer. Now let's quickly run this. So it's giving us the correct answer. Let's submit it. And it got accepted. Now talking about the time complexity and space complexity. So if we consider n as the size of the array, then the time complexity is order of n. Why? Because here you can see that what we are doing, we are iterating over all the n elements of the array to populate this answer, right? What we are storing in this answer, here we are storing the prefix product. And again, what we are doing over here, we are again iterating over all the n elements to populate our answer, like to calculate the suffix and to multiply it with the answer of index to get the answer, right? So the time complexity in total would be order of 2n, which is ultimately order of n only. And the space complexity would be order of 1 because we are not using any extra space from our end, correct? So that's all about today's daily LeetCode challenge. Thank you.